The awakening titan inside the Yellowstone Caldera. The ground beneath the pristine wilderness of Wyoming begins to groan. Somewhere deep in the upper geyser basin, a thermal pool that has remained calm for decades suddenly erupts with a violent, muddy surge. Steam hisses through new cracks in the earth, and the smell of sulfur becomes thick enough to choke. This is not a tourist attraction. This is the first breath of a giant. High above, satellite data reveals a chilling reality. A massive section of the park, miles across, has inflated like a slow-moving bubble. The Earth is stretching. This is the heartbeat of the Yellowstone supervolcano, a geological force so immense that its previous eruptions buried half of North America in ash. If it decides to wake up, the map of the world will never be the same. Yellowstone National Park is often celebrated for its breathtaking beauty, its wandering bison, and its iconic geysers. However, beneath this picturesque landscape lies one of the most dangerous geological features on Earth. Known as a rhyolitic caldera, Yellowstone is not a traditional mountain-shaped volcano. Instead, it is a massive crater in the ground, measuring roughly 34 by 45 miles. This depression was formed by three cataclysmic eruptions over the last 2 million years, the most recent occurring 640,000 years ago. To understand the scale of the threat, one must look at the plumbing system of the park. Beneath the surface lies a vast reservoir of molten rock, known as a magma chamber. Recent seismic imaging has revealed that this chamber is even larger than previously thought, stretching for dozens of miles and reaching depths of up to 28 miles. It is a pressurized cauldron of liquid fire, fueled by a hotspot in the Earth mantle that has been burning for millions of years. The current state of Yellowstone is a subject of intense scientific scrutiny. Geologists monitor the area around the clock using a network of seismographs, GPS stations, and thermal sensors. In recent years, data has shown a phenomenon known as ground deformation. Certain areas of the caldera floor have been rising and falling in cycles. While this is often attributed to the movement of hydrothermal fluids and gases rather than magma, the sheer scale of the uplift is enough to cause concern. When the ground rises, it indicates that pressure is building. One of the most visible indicators of the volcano health is its hydrothermal system. Yellowstone contains more than half of the world's geysers and hot springs. These features are created when groundwater seeps down, is heated by the magma below, and rises back to the surface. However, when the system becomes unstable, it can lead to hydrothermal explosions. These events occur without warning, turning peaceful pools into deadly fountains of boiling water and rock. Recent spikes in geyser activity and the appearance of new thermal areas suggest that the heat transfer from the magma chamber is intensifying. The historical record of Yellowstone is a timeline of destruction. The three major eruptions produce hundreds of cubic miles of ash and rock. The Huckleberry Ridge eruption, 2.1 million years ago, was one of the largest individual volcanic events known to history. It created a layer of ash that covered much of the western United States. If a similar event were to happen today, the immediate impact would be catastrophic. The area within 100 miles of the park would be incinerated by pyroclastic flows, fast-moving clouds of hot gas and volcanic matter that move at hundreds of miles per hour. Beyond the immediate blast zone, the fallout would be a global crisis. A massive ash cloud would rise into the stratosphere, blocking out the sun and causing a volcanic winter. Temperatures across the globe would drop significantly, leading to widespread crop failure and famine. The electrical grid and transportation systems would be paralyzed as ash clogs engines and shorts out power lines. It would be a challenge to human civilization on a scale never before seen in recorded history. Despite these grim possibilities, it is important to analyze the likelihood of such an event. The United States Geological Survey and the Yellowstone Volcano Observatory emphasize that there is no evidence an eruption is imminent. The probability of a super eruption occurring in any given year is extremely low. Most volcanic activity at Yellowstone consists of small earthquakes and hydrothermal shifts, which are normal for a living volcanic system. However, the unpredictability of nature means that scientists can never be entirely certain when the next major cycle will begin. The mystery of Yellowstone lies in its silence. For thousands of years, the park has remained the place of wonder, but the geological clock is always ticking. The shifts in temperature, the rising ground, and the restless geysers are all reminders that we are guests on a planet that is still very much alive. The caldera is a sleeping monster, a force of nature that commands respect and demands constant vigilance. As we look to the future, the study of Yellowstone provides vital clues about the inner workings of our planet. By understanding the mechanics of this supervolcano, scientists hope to develop better early warning systems for volcanic activity worldwide. For now, the tourists continue to flock to Old Faithful, unaware that they are standing on the roof of a giant. The beauty of the park hides its true nature, a delicate balance between the peaceful surface and the raging fire below. In the end, Yellowstone remains a testament to the power of the Earth. It is a reminder that human history is but a brief moment in geological time. Whether the monster stays asleep for another 100,000 years or begins its final awakening tomorrow, it serves as a profound symbol of the forces that shape our world. We watch, we listen, and we wait, hoping that the giant beneath the pines remains in its long, deep slumber.